Alright guys, I know we didn't finish in class. I wanted to make sure I made a video about the last problem that we didn't get to cover here. So please pause the video and go ahead and copy down the problem that we have, and then press play when you are ready to go. Okay? Alright, so I'm going to assume you've already paused the video and you have the problem down, so let's talk about it. So we have a state game commission that's going to release 40 elk into game refuge. After 5 years, the elk population is 104. The commission believes that the environment can support no more than 4,000, this should be a 4,000, I'm sorry, 4,000 elk. The growth rate of the elk population is P is given by the following differential equation. dP over dt equals to Kp times 1 minus P over 4,000, where the population has to be greater than 40 but less than 4,000. Okay. We're going to write down, by the way, T is going to be in years. So the first thing that I need to do is we're going to write a model for elk population in terms of time. So in this case, we say time in years. Okay. So in other words, I'm coming up with an equation that would give me the population at any given time. All right. So any suggestions of what I can do? Well, I'm looking at this thing. I'm looking at the differential equation that was given to me. And I remember that in class, I provided you with this differential equation, but without plugging in numbers. If you remember, well, by the way, the one that I provided with you was, I believe, dy over dt, which made this to be ky times 1 minus y over L. And if you remember L represented this number right here, which represents the carrying capacity. Okay, well, remember that if I want to write a model for this, that means that I have the derivative of this, so now I have to anti-differentiate. Or if you remember, rather than anti-differentiating and going through that process, if you remember what the antiderivative of this looks like, or if you memorize it, then this should be no problem. Well, remember that this is basically going to look like y equals to L over 1 plus b e raised to the negative kt. So we found out during class about that. Well, that's where I need to go, and I need to find out all this missing constants. So I need to find out what b is, I need to find out what k and L is. L, fortunately, we already know. So this is actually for us going to become 4,000 over 1 plus BE negative KT. Okay, well, that's what I have so far, but the problem gave me some information. It helped me figure out what this B is and what this K is. To begin with, you know that at the beginning, so when time equals 0, so when t equals 0, you had 40 elk. So we some of these missing variables. So here's what I know. That means that if I have population at time 0, that's going to be equal to 4,000 over 1 plus b e raised to the negative k times time, which in this case is 0. And according to that, I should have 40 elk. Well, then looking at this, I'm going to simplify things out. So I have 4,000 over 1 plus, well, anything times 0 is just going to be 0. E to the 0 power is just going to be 1, so b equals to 40. Cool. So at this point, then I'm just going to algebraically solve this. So I'm going to just cross multiply and subtract. So this becomes 40b equals to 4,000 minus 40. Therefore, that means that b is equal, well, 4,000 minus 40 is going to be 3,960 divided by 40. And let's see, the zeros can go away. So 4 goes into 39 9 times, and you're left with 3. And then 3, 6, 99. Okay, so that should be 99. Alright, so here's what we know so far then. We now know that P of t is equal to 4,000 over 1 plus 99 e to the negative kt. Awesome. So we've made a lot of progress. The only thing that we have left to figure out is k. Well, do I have more information? Well, if I go back to the problem, I know that after 5 years you had 104 elk. So maybe I can plug this information into the equation and figure out what k is. So that means that p after 5 years, the population will be 4,000 over 1 plus 99 e to the negative 5t. I mean negative 5k, I'm sorry, not t, because that's what we're looking for. We're looking for k, I'm sorry. And from here, we're just going to kind of solve this algebraically. So I want you to pause the video and try this on your own. I would encourage you to use a calculator. By the way, I'm sorry, this was equal to 104. So use your calculator and try to figure out what k is. Okay? So pause the video and then come back when you're ready. Alright, so I'm assuming you've already paused the video and you try to do this. So here I showed you all my work. Honestly, if you have a calculator, I wouldn't even bother doing all this algebraic work. I just kind of want to show you what happened here. But eventually you get that k is equal to 0.194. So what that means is that now that you have all of your constants and you're ready to give me the model, which is p of t equals to 4,000 over 1 plus 99 times e raised to the negative 0.194 t. Okay? So here we go. We got now ourselves a model for the population of elk at any given time. Let's start at part B. So now I want you to estimate the population 15 years later. So at 15 years, after 15 years from the beginning. Well, think about it. This is very simple. So we already have the model, so we need to do P of 15, which is 4,000 over 1 plus 99 e to the negative 0.194 times 15. And we're going to plug it in our calculators and see what we get. So try it and come back. Alright, so I'm hoping you tried this already. So when I plug this into the calculator, I got about 625.67. Since we're talking about a population, it's impossible for you to have 2/3 of an elk. So that means that you have about 625 elk after 15 years. Okay. Last thing I want to check with you is I want you to verify the carrying capacity. Capacities. So you just gotta make sure you can verify what it is. Okay. So in this case, remember that the carrying capacity according to the problem is 4,000. So you gotta verify that it is. So in other words, you gotta check that the limit as time approaches infinity of this function is in fact 4,000. Okay. So remember, if I evaluate the limit as t approaches infinity of 4,000, that's just gonna give me 4,000. That's just going to give me 1 for the constant. And think about it. As this gets larger and larger and larger and larger and larger and larger, this approaches 0. Okay? So, as it gets larger and larger and larger and larger, then this gets smaller and smaller and smaller and smaller and smaller and smaller, which means that eventually this is going to reach 0 or approach 0. Therefore, the limit as t approaches infinite time is equal to 4,000, and we have successfully verified that the carrying capacity is 4,000 elk. Alright, that's all I got for you. Homework is on the hub. Thank you for watching, and I'll see you next class, guys.